Thank you so very much for joining us once again. I'm back here today, and I'm back for physics. And today we are going to look at what we call kinetic energy of a satellite. Now, most of you think satellites are machines only, but satellites are actually terrestrial bodies. As long as one body revolves around another body, the revolving body is called a satellite. So there are two categories. We have the natural satellites, we have the artificial satellites. The examples of natural satellites are the moons. The other artificial satellites are the ones that we use for telecommunication and World Wide Web. Yeah, so they were built for mainly communication. But the moon behaves as a natural satellite in the sense that it has been there and it is revolving around the Earth. The Earth behaves as a natural satellite to the sun because the Earth also revolves around the sun. So as long as the terrestrial body revolves around another body, that revolving body is called a satellite. So we have a satellite. It can be at a position like this one, at a distance r from the center of a given planet to where the satellite is, because r, the radius of the orbit, is always measured from the center of the planet. The force they will experience, this satellite will experience a force due to centripetal force, which is mv squared, the force experienced by bodies moving in circular paths. So all bodies you see in the sky, they are moving in circular paths, ranging from the stars to the moons to the planets to the asteroids to anything you can think of in the sky. Even the natural satellites we have that broadcast our football, that broadcast our telecom information, that do channel for us all our data that we are trying to move on our phones. As long as they reach the satellites, then they are experiencing centripetal force, as in the satellites we are talking about up there. Now, more to that, the satellite also experiences the force of attraction as per Newton's law, which is the force due to universal gravitational constant, capital G, the mass of the planet, in this case we are talking about the Earth, the small mass m for the satellite, which is revolving around the Earth, then the r, which is the distance between the two bodies. The force due to the centripetal force, therefore, is provided. The centripetal force is provided by the force of attraction. By the force of attraction. And it is from this note that you'll have capital GMM out of r squared is equal to small mv squared out of r. If I lose one r, I'll remain with one r down there, and I'll have the following expression. Capital GMM out of r is equal to small m v squared. Now, at this point, we can think outside the box a little and introduce a useful one. The useful one I want to think about is a useful RF on both sides. If I multiply on both sides by RF, this RF mv squared actually corresponds to kinetic what? Energy. Therefore, the kinetic energy of a satellite in space is the same as capital GMM out of 2r. And this is the expression for kinetic energy for any body that is in space. Even if it's a space vehicle that is up there, the kinetic energy it will possess can be defined by this expression, depending on the distance where it is and depending on the size of its mass. Now, earlier on, if you've watched all our videos and you've been following them, one time we looked at what we called potential energy. Potential energy is given by a negative GMM out of r. Now, since I have kinetic energy and I have potential energy, I can consequently deduce what we call the total energy of the satellite, which total energy of the satellite is what we are going to call the mechanical energy of the satellite, which is the same as the potential energy plus the kinetic energy of the satellite. So if you add these two, we shall realize the following: a negative GMM out of r plus capital GMM out of 2r, and this will take us to, this is a half of that, though it's a negativity, it will give us a negative GMM out of 2r. Therefore, mechanical energy of a satellite is always a negative capital GMM out of 2r. To begin with, mechanical energy is negative. Secondly, it is the same expression as kinetic energy, meaning mechanical energy of a satellite in space has the same magnitude as kinetic energy. But it's just that mechanical energy has a negative sign. That negative sign, I explained it in one of the videos earlier on, which is the sense that the energy is negative because of one reason. We do work against the electrostatic force of attraction, because this force of attraction is trying to pull this mass close to it, or to pull this satellite close to the planet, and for you what you're trying to do is to do work to get the satellite out of the orbit. So once you do that work, you're doing work against the electrostatic force of attraction between the satellite and the planet. Hence the work you end up doing becomes a negative. There's also another relevancy for this, that if a satellite, for example, is falling back to the Earth's surface, the radius can be reduced, and when the radius reduces, the kinetic energy will end up increasing. Therefore, whenever bodies are falling back to the Earth, their speeds increase. That is the reason why when a body is thrown upwards and comes back down, by the time it comes back to my hands, the speed is very high, or almost the same velocity as what it left with. So whenever bodies are falling back, speed increases. Whereas when the distance is reducing as it's falling down, when it reduces, it induces a very big fraction. A very big fraction, which is a negative, is a small value. So the potential reduces. In the normal setting of potential energy is mgh. Whenever height reduces, potential will reduce. Consequently, also mechanical energy will reduce, and if the satellite precautions are not taken, the satellite may burn. Sometimes also those are effects of frictional force which we experience from the sky due to the collisions with the air molecules in the atmosphere. So today, I have been sharing with you what we call kinetic energy, and consequently, I've also deduced what we call mechanical energy. And from that sense, we have seen the reasons why a satellite may end up losing some of this energy if it's falling back to the Earth's surface. I'm still the same. Thank you for liking our videos, for watching and sharing. If you've forgotten to subscribe, please hit the button and tell a friend to tell a friend. See you next time.